Welcome to 11.3. We're going to be graphing something called inequalities. Right, so we're going to show on the number line any way you can, where are the numbers greater than 4? Well, bigger or greater is always that way. So the numbers greater than 4 are this way, right? And we have to include 5, obviously, and 1,000,000 and 73. We also have to include 4.0000001. So how are we going to do that? But we should not include 4, right? Because we don't want to include 4. So the way you do that is you put a circle that you can see through on 4. And then you're going to draw an arrow. Now you're not going to draw the arrow up here like we did for adding and subtracting. No, this arrow is sort of ugly because it covers up the number line and then shows, this is how you show all the numbers greater than 4. To show all the numbers less than -5, right? Well, same idea, right? The numbers that are less are always this way, right? -1,000,000 is a very small number. So we have to show -1,000,000. We also have to show -5 1/4 and -5 and right, because both parts of that are negative, or -5.00003. So we do it the same thing we did with the +4. You're going to put an open circle on -4, and you draw this ugly arrow. The arrow must be connected to this circle, must be connected to the circle. What length it is up to you, but it is not up here, even though that does look prettier. This is the way you show numbers on a number line. And so this shows all the numbers, and there is an infinite amount of them, that are less than -5, and the red one shows all the numbers that are greater than +4. Where are all the numbers greater than -3? So you do an open circle on -3, and all the numbers, including -2.999, are this way. All right, so this is called an inequality. Right? In is a prefix that means not, so this literally means not equal. It's not an equation. Right? It's an inequality. Now, you're going to what does that say? It says x or all. We're going to say all numbers. You could say any numbers. You could say x, because that's what x is. All numbers greater than 11. That's greater than. So what is that, right? So that's all numbers. And we actually, let's make it a sentence. I'm going to put are in there. Are, right? We don't have a verb. All numbers are greater than 11. All numbers are less than -2. Now, you know, different teachers have different things. I would just memorize these, but if you forget, the one that sort of looks, and it sort of looks like an L, is the one that goes with less. Unfortunately, the one that sort of looks, that's greater, does not sort of look like a G at all. All right, copy the numbers that are possible for x is greater than 11. So not -4, not 0, not 11. 11.1, 12, that's 12.5. That's not 12. 12.5 and 80. They're all numbers that are greater than 11. Copy numbers that are possible for x is less than -2. All numbers are less than -2. So -25, -6, -3, not -2, not 0, not 1, not 8. Right? But when we're doing all numbers, we're including decimals and fractions. We often deal with the nice integers, right? Whole numbers that are positive or negative, but the fractions and decimals are there. All right, so we're going to graph an inequality. So we're graphing all the numbers. All the numbers are greater than 6. Okay, so how do you graph that? So you're going to show 0 on the number line every time. Then we're going to show +6, right? Positive is always on this side. We never switch it. So that's where +6 goes. Now, right, we have to show all the numbers that are greater than 6. And that it's going to include 6.0001, but not 6. So how do you do that? You show an open circle on 6. Now notice I didn't put any tick marks over those little lines are called tick marks or over there. I'm just going to put the tick marks that I need each time to go faster. So if some of you have gotten in the habit of always putting -10 to +10 on a number line, don't do that. It's a waste of time. Just take enough tick marks to show that you know where +6 is, and then you draw that ugly arrow that shows all the numbers that are greater than 6. The arrow must be attached to the circle. It can be any length, but it's covering up the number line. It is not up there, sorry. All right, so that's all the numbers are less than 2. All the numbers are less than 2. So we show +2 right there. Yes, we'll do negatives in a second. Open circle on 2, because one of the numbers could be 1.9999. And then all the numbers that are less than 2 go this way. This is attached, and that's what you do. All right, so what is that? That's all the numbers are greater than -3. So you show 0 on your number line, then you go 1, 2, -3, right? -1, -2, -3. It's all the tick marks you need. Now, open circle, but we need numbers greater than -3. They're this way. Greater is always this way. Less is always that way. Yes, and this do match every time, but I'd rather you just know that greater is always to the right. So what are all the possible solutions of the graph? All right, not -10, not -3, because we need numbers greater. -1 though is greater than -3. 0 is greater than -3, 2.5, 8, 9.5, all those. All right, so now we're going to add an extra line. When you see this extra line underneath there, that's or equal to. What they did was they took a greater than symbol and they took an equation and they combined them. And they put one of the equal things underneath there. I think that's very logical. Now when you have that, that means it also could be equal. So you're going to fill in the circle now. So there's two things when you graph these to know. Which way does the arrow go? And do you fill in the circle or not? All right, so this is all the numbers are greater than, or, and it's not and, it's or equal to 3. So how are we going to show that? It's a sentence. So we go to +3, but now you're going to fill in your circle on 3. That's showing it's 3.001 and 3. But not 2.999. 3 and greater. So now you fill in the circle. Greater is still in that direction. And that's still considered an inequality, even though it's a combination of an inequality and an equation. We still call it an inequality. So what is that? That's all the numbers are less than or equal to 7. So we're going to show 1, 2, 3, 4, 5, 6, 7. We're going to close the circle in now. And the numbers less than 7 include 6 and 1. And every negative number is less than 7, right? There is no negative number that's bigger than 7. And make sure your circle is very clearly closed in, especially on the test. All right, so that's, what is that? That's x is, all the numbers are x is less than or equal to -5. So you show 0, then you show 1, 2, -1, -2, -3, -4, -5 is right there. We're going to close in our circle because there's an or equal to, and that's less than. So x is less than or equal to -5. No, you don't have to write the sentence out every time. That's unless you're asked for that. The graph, this is the graph. Copy numbers that are possible solutions of the graph. Well, -30, -6, -5, yes, because we have the or equal to, nothing that is bigger or larger than -5. All right, so now one of the trickiest phrases in the English languages are on the top of the screen. You should take these notes. At most and no more than mean less than or equal. If I say I have at most $50, or I have no more than $50, that means I have $50 or less. I have less than or equal to. Yeah. If I say I have at least or no less than $7, I have $7 or more. It means greater than or equal to, right? So this is tricky, especially if you haven't seen these words in your normal course of language. So let's see that. A number is at least 7. Is X is greater than or equal to 7. At least 7 means you have 7 or more. So 1, 2, 3, 4, 5, 6, 7. We're going to close in our circle. Yeah, some people get that you have to, that at least means greater, but it's greater than or equal to 7 or more. So you have to fill in the circle. You're always going to be filling in the circle with any of these phrases. Then you have to make sure you put the arrow in the right way, right? 8 is at least 7. 7 is at least 7. A million is at least 7. 6 is not at least 7. A number is no more than -4. It is -4 or less. So -1, -2, -3, -4. You're closing in the circle, and no more than -4 is this way. Close that circle in. All right, so what does that say? Again, I want you to put in at least or at most. That number is at least, right, because we're going that way, and that's 1, 2, 3, at least 4 is the sentence. At least 4, 4 or more. The number is at most, what? That looks like I didn't really leave enough room, unless you write it as a number. At most, -1. That's -1. It is no more than -1. All right, so let's practice. So X is less than 5. So 1, 2, 3, 4, 5. You show 5. You put an open circle less than 5 this way. X is greater than or equal to -4. -1, -2, -3, -4. Close the circle in because it's or equal to, and greater than is this way. X is less than or equal to -7. -1, -2, -3, -4, -5, -6, -7. We're going to, notice I put the number that we have, but I don't put any other numbers other than 0, but I always put 0. We're closing that circle, and it's less than or equal to -7. It's that way. And the length of the arrow is not important, but that it's attached to the circle is, and obviously the direction. Where is 2.5? Well, 2.5 is halfway between 2 and 3. It's one of the reasons you write the number. It could be a decimal. It's an open circle because its X is greater than 2.5. So 2.5001 and a million are both greater than 2.5. The number is at least -1. Copy numbers that are possible solutions. Not that. Those are both smaller than -1. Yep. -1, yes, 0, 1, 56. They're -1 or bigger, at least -1. Good luck on the homework.